Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability. Our channel is dedicated to bringing you the latest innovations and insights in green energy, including cutting-edge developments like green hydrogen. Whether you're a sustainability veteran or just beginning your journey, we have something for everyone. Join us on this channel to explore inspiring projects for a sustainable tomorrow. We bring you the latest in renewable energy, sustainability, and cutting-edge technologies. And don't forget, for more in-depth information and resources, visit our website and subscribe to our newsletter for the latest updates and exclusive content. Hey everyone, and welcome back to ReneEnergy.com, your go-to channel for all things related to clean energy and sustainability. Today, we're going to take a deep dive into the world of electric vehicles, EVs, and hydrogen fuel cell vehicles. We'll explore their fascinating history, the cutting-edge technology behind them, their advantages and challenges, and the current state of the market. So, buckle up and get ready for an exciting and informative ride. Let's start with a brief history of EVs. Believe it or not, electric cars have been around for over a century. In fact, some of the first vehicles ever made were electric. Way back in the late 19th and early 20th centuries, EVs were quite popular, especially in cities where their quiet operation and lack of emissions were appreciated. However, with the rise of cheap gasoline and the invention of the electric starter for internal combustion engines, EVs began to decline in popularity. By the 1930s, they had all but disappeared from the market. Fast forward to the 1990s, and concerns about air pollution and climate change sparked a renewed interest in EVs. Major automakers began developing new EV models, and advances in lithium-ion battery technology made them more practical and affordable. In the early 2000s, a new player emerged in the EV market, Tesla Motors. Founded by entrepreneur Elon Musk, Tesla set out to prove that EVs could be not just environmentally friendly, but also stylish, high performance, and desirable. Now, let's talk about the basics of EV technology. Modern EVs use lithium-ion batteries to store energy, which powers an electric motor to drive the wheels. These batteries are made up of thousands of individual cells, each containing an anode, a cathode, and an electrolyte. During discharge, lithium ions move from the anode to the cathode, releasing electrons to power the motor. During charging, the process is reversed, with lithium ions moving back to the anode. EV batteries can be charged using either AC or DC power. AC charging, also known as level 1 or level 2 charging, uses a standard household outlet or a dedicated EV charging station to deliver power to the vehicle's onboard charger, which converts the AC power to DC to charge the battery. DC fast charging, on the other hand, delivers high-voltage DC power directly to the battery, bypassing the onboard charger and allowing for much faster charging times. One of the key advantages of EVs is their high efficiency. While gasoline-powered vehicles typically convert only 20 to 30% of the energy in the fuel into motion, EVs can convert around 80 to 90% of the energy stored in the battery into motion. This means that EVs require less energy to travel the same distance as a gasoline-powered vehicle, resulting in lower operating costs and reduced environmental impact. But what about hydrogen fuel cell vehicles? These use a slightly different technology, where hydrogen gas is converted into electricity by a fuel cell to power the electric motor. In a fuel cell, hydrogen gas is fed into the anode, while oxygen from the air enters the cathode. A catalyst at the anode splits the hydrogen molecules into protons and electrons. The protons pass through an electrolyte membrane to the cathode, while the electrons flow through an external circuit, generating electricity to power the motor. At the cathode, the protons, electrons, and oxygen combine to form water, which is the only emission from the vehicle. Hydrogen FCVs have some advantages over battery EVs. They typically offer longer driving ranges, as hydrogen has a higher energy density than batteries. They also have faster refueling times, as filling up a hydrogen tank takes only a few minutes, compared to the 30 minutes to several hours needed to charge an EV battery. However, hydrogen FCVs also face some significant challenges. The cost of fuel cells and hydrogen storage systems is still quite high, and the infrastructure for producing and distributing hydrogen is currently limited. So, what are the overall pros and cons of EVs and hydrogen FCVs? On the plus side, both technologies offer the potential for zero tailpipe emissions, which can greatly improve air quality and reduce greenhouse gas emissions. EVs have the added advantage of being highly efficient and having lower operating costs than gasoline-powered vehicles. They also have fewer moving parts, which can result in lower maintenance costs over the life of the vehicle. However, EVs also face some challenges. One of the biggest is range anxiety, the fear that the vehicle will run out of power before reaching its destination. While the range of EVs has increased significantly in recent years, with some models now offering over 400 miles on a single charge, many consumers still perceive them as having limited utility for long-distance travel. Another challenge is the time required to charge an EV battery. Even with DC fast charging, it can take 30 minutes or more to charge a battery to 80% capacity, which can be a significant inconvenience for drivers who are used to the quick refueling times of gasoline-powered vehicles. The cost and lifespan of EV batteries are also potential concerns. While the cost of lithium-ion batteries has fallen dramatically in recent years, they still make up a significant portion of the overall cost of an EV. Additionally, EV batteries degrade over time, losing capacity and range as they age. Most manufacturers offer warranties of 8 to 10 years or 100,000 to 150,000 miles on their batteries, but the long-term durability and replacement costs are still uncertain. Hydrogen FCVs face their own set of challenges, primarily related to cost and infrastructure. Fuel cells and hydrogen storage systems are still quite expensive, and the cost of producing and distributing hydrogen is currently much higher than gasoline or electricity. There are also very few hydrogen refueling stations available, which limits the practicality of hydrogen FCVs for most consumers. Despite these challenges, both EVs and hydrogen FCVs are gaining momentum in the market. Global EV sales have been growing rapidly in recent years, with over 3 million units sold in 2020. However, market share varies widely by region. EVs account for around 10% of new car sales in Europe, 5% in China, and just 2% in the United States. Some of the leading EV models include the Tesla Model 3, Nissan Leaf, and Chevrolet Bolt. The market for hydrogen FCVs is much smaller, with only a few thousand units sold globally each year. However, countries like Japan, South Korea, and the United States, particularly California, are investing heavily in hydrogen refueling infrastructure and have set ambitious targets for FCV deployment. Hyundai and Toyota are among the leading manufacturers of hydrogen FCVs, with models like the Hyundai Nexo and Toyota Mirai. Looking to the future, the outlook for EVs and hydrogen FCVs is promising, but uncertain. The International Energy Agency projects that the global EV fleet could reach 145 million vehicles by 2030, accounting for around 7% of the total vehicle fleet. However, the pace of EV adoption will depend on a variety of factors, including government policies, battery costs, charging infrastructure, and consumer preferences. The growth of the hydrogen FCV market is expected to be slower, but still significant, with projections of 2.5 million FCVs by 2030. The success of hydrogen FCVs will depend largely on the development of a robust hydrogen production and distribution infrastructure, as well as continued cost reductions in fuel cell technology. There are several key factors driving the adoption of EVs and FCVs. Government policies, such as subsidies, tax incentives, and regulations requiring automakers to produce zero-emission vehicles, have played a significant role in promoting EV adoption. The declining cost of lithium-ion batteries has also made EVs more affordable and competitive with gasoline-powered vehicles. Consumer awareness of the environmental and economic benefits of EVs is also growing, thanks in part to the success of companies like Tesla in making EVs desirable and aspirational. In conclusion, the future of transportation is electric, and both EVs and hydrogen FCVs will likely play a significant role in the coming decades. While there are still challenges to overcome, the benefits of these technologies are clear: reduced emissions, improved air quality, lower operating costs, and a more sustainable energy future. As battery and fuel cell technologies continue to improve, and charging and refueling infrastructure expands, we can expect to see even more rapid adoption of EVs and FCVs around the world. So, what do you think? Are you excited about the future of electric and hydrogen-powered transportation? Do you own an EV or FCV, or are you considering buying one in the near future? Let us know in the comments below, and don't forget to like and subscribe to ReneEnergy.com for more great content on clean energy and sustainable living. Thanks for watching, and we'll see you next time. Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode enlightening and motivating. There's a world of innovation and opportunity in sustainable energy, and we're delighted to share this journey with you. Stay in the loop with the latest on renewable energy and sustainability by visiting our website and subscribing to our newsletter. Your support is immensely appreciated, it's truly invaluable to us. Don't miss our next video on new trends in renewable energy. Follow us on social media for the latest updates. Enjoyed the video? Like, subscribe, and share for more green insights. Thanks for watching.